Alright, in this this is 2.6, looking at the WebAssign questions. Keep in mind, or actually this is the odd problems. Keep in mind this is available to you when you go to your Canvas page and look up files. This is part of the 2.6 notes. It's the odd problems out of the textbook, and it's an excellent thing to review and or to try and do on your own, and then just double check with my work. I do all the odd ones all the way up through to 51. Let's look at 2.6. These are all questions similar to the ones on WebAssign. They're in the order you see them on your WebAssign assignment. So they say use the graph below to figure out what limit as x approaches infinity. Well, if you go up to infinity, you're approaching minus 2. If you go up to minus infinity, you're approaching positive 2. What's happening at 1? Well, in both directions, both sides, it goes up to infinity, so you can say that it's infinity. At 3, they both go to minus infinity, so you can say it goes to minus infinity. It's got two vertical asymptotes, one at x equals 1, another one at x equals 3. It's got two horizontals at x equals 2 and x equals minus, or y equals 2 and y equals minus 2. Question 8. What's happening as x goes off to minus infinity? Well, it's going to minus infinity. It's not settling down to anything. What's happening? It goes off to positive infinity. Well, it shoots off in the positive direction, so positive infinity. So now what's happening at negative 2 from the left and the right, and then at positive 2? Minus 2 from the left, it goes off to infinity. Minus 2 from the right, it goes to negative infinity. And then at 2, on both sides, it goes to positive infinity, so its answer is positive infinity. Number 12, use a graph of this to estimate the values as x goes off to infinity. So as you go off to the right, you can see it's settling down to a certain number. Remember, this is 0.5 and this is 0, so that actually settles down to 0.1353 is a good guess or estimate that we could say is the answer to that limit. Now the rest of these are they're just asking you to find the limit or show that the limit does not exist. So the technique we're going to use is we're going to divide by the highest power in the denominator, in this case t squared. Divide every term by t squared, reduce it. And anything where you have t in the denominator is going to go to 0. 0, 0, 0. That one goes to 6, that one goes to minus to 2. So you end up with 6 over negative 2 or 3. Here you divide by x everywhere, and you get to here. And both of these go to, both these guys go to 0, and you're left with 4 over 5. Here you divide by t cubed, and so you end up with 3 over t, actually. And that's 3 over t, not 3t. And 3 over t goes to 0. 1 over t squared goes to 0. This goes to 1. 4 times 0 plus 0. So you end up with 0 over 1, which is 0. Here your highest power is x to the 1/2 or square root, so you divide by the square root of x everywhere. And here you just get 4 over square root of x, but here you get a 1. And here you get 2 over square root of x, and there you get a 1. Now as you plug in infinity, your denominator explodes, and that goes to 0, and that goes to 0. So you're left with negative 1 over 1, which is just negative 1. Here you divide by x, and when you plug x into the numerator, you have to move it into the square root, under the square root, so it actually squares, becomes x squared, and you divide it into both terms, and you get x over x squared is 1 over x, 3x squared over x squared is just 3, 4x over x is just 4, 1 over x is just 1 over x. Remember, you're dividing every term by x, and when you move the x into the square root symbol, it becomes x squared. Now this and this go to 0, but the other two stick around, and you end up with square root of 3 over 4. Here you're dividing by x cubed, and when you move it into the square root, it becomes x to the 6th. So you're dividing 1 over x to the 6th, and 4x to the 6th over x to the 6th gives you just 4. So this part is going to go to 0, that goes to 4, that goes to 0, that goes to 1. So you got the square root of 4 over negative 1, which is just negative 2. And this one you got to multiply by the conjugate of this number, so this add this. And when you do that, the top reduces down to just 2. The bottom gets more complicated, but so what? And we divide by t everywhere. 2 over t, 5t over t, and this guy over t. And again, when you move it into the square root, it becomes a t squared. So 25t squared over t squared is just 25. 2 over t squared is 2 over t squared. So this goes to 0, that goes to 0, and so down here you got square root of 25 plus 5, which is 5 plus 5 or 10, and the square root 0 over 10 is just 0. This one they ask you to figure out how this one is working, and it's just the square root of x squared plus 11. And as you plug infinity in here and square it, it's infinity. Plus 11 is even more infinity. And square root of infinity is infinity. Now in this one, you divide every term by x squared. Even though you have an x cubed in this, you divide by the highest power of the denominator. So you divide everything by q squared, and it reduces down to here. Okay, and all these with a q in the denominator go to 0, 0, 0, 0. 4 goes to 4, but the q is going to go off to infinity. Infinity over 4 is infinity, because the top will go to infinity, 0, 0, and that goes to infinity. The bottom goes to 4, because that's 0, 0, and that stays a 4. So infinity over 4 is going to be infinity. On this one, it's just like number 29. You multiply by the conjugate, you reduce, and now you divide the top and bottom by x. And when you divide the square root of x by x, you get the square root of x over x squared, which is 1 over x. And now down here, this part, as you plug in infinity, that's 0, so the denominator is 1. But the numerator is infinity. Infinity over 1 is just infinity. On this one, you're going to divide top and bottom by e to the x. And you get 1 over e to the x, and you get 1 here. You get 1 over e to the x, and you get 2 here. And so as you plug infinity into e to the x, it gets huge, and that goes to 0, so does that. And you just left with minus 1 over 2. Now here you have to use the squeeze theorem. So best way is to start with something that you know how far it ranges, and we know cosine goes from minus 1 to 1. Now we need to know what this guy times cosine is, so let's multiply each one by e to the negative 2x. And we also know that e to the negative 2x is always positive. Okay, so you can multiply these three and still hold the inequality true. Remember, e to the negative 2x is 1 over e to the positive 2x, and that's greater than 0. Alright, so you multiply each one by e to the negative 2x, and you get this. Now, squeeze theorem says if you got an f, a g, and an h functions, and you know that f goes to one number, and the limit of f goes to one number, the limit of h goes to the same number, then the limit of g has to be that same number because it's sandwiched in between. So here's the limit of f, the left-hand side, and you got 0. Here's the limit of h, and it goes off to 0. And so we know the limit of this guy also has to equal 0. Alright, so on this one, if you looked at the graph, you see that you have a horizontal asymptote and a vertical asymptote. Vertical is where your denominator equals 0, and that's x equals negative 3. Horizontals are found by taking infinite limits, and so we're going to divide everything by x here. And we know as we plug in infinity or minus infinity, that goes to 0, that stays at 4, that stays at 1, and that goes to 0. And so you end up with 4. And so y equals 4 is your horizontal asymptote. Now on this one, you would expect 2 verticals and 1 horizontal. So your verticals are where your denominator equals 0, and we factored it and set each one equal to 0, and we got our two verticals. Our horizontal is found by going off to infinity. So we look at each one and we divide every term by the highest power of the denominator, which in this case is x squared. And when you do and you reduce it, you get here. Now 1 over x squared, 2 over x, and 1 over x squared are all going to go to 0. But the 2 and the 3 are going to go to just 2 and 3, respectively. And so your limit is 2/3, so y equals 2/3. Now in this one, if you factor the denominator, you get these three terms. Setting each one of those equal to 0 gives you these three values for x, and those are the vertical asymptotes, places where you're dividing by 0. Now as you go off to infinity, you divide by the highest power here, x to the 4th, every term. You end up with this, because x to the 4th over x to the 4th is 1. Okay, so this guy and this guy are going to go to 0 as you go off to infinity. And so you're left with just 1 over -1, which is -1. And that's what your graph looks like. You got vertical asymptotes here, here, and here. And you got another horizontal asymptote right there at -1. Okay, now this one, let's look at the horizontals first off. Let's take the limit as we go up to infinity of this guy, and we divide by e to the x everywhere. That guy just gives you 2, that guy just gives you 1, and this guy is what it is. Now as you go up to infinity, this guy goes to 0, and you end up with 2 over 1 or 2. So your horizontal asymptote is at y equals 2. Now if you go up to minus infinity, by the same token you get the 1 over 2 minus 5 over e to the -x. And so, well actually you don't want to do that, I'm sorry. You stick with the original function, and when you plug in a negative infinity for this, this becomes 2 over e to a positive infinity. 2 over e to a positive infinity is 2 over an infinite number, which is 0. And e to the negative infinity is 1 over e to the positive infinity. Remember, e to the infinity is a huge positive number, so 1 over a huge positive number is 0. So you get 0, 0, and -5, and so that gives you 0. Horizontal asymptote at 0. Now vertical is where your denominator equals 0. So this guy equals 0, add 5, you get this. And now to figure out what x is, you got to use logarithms. So log base e of 5 equals x. So there's your equation, x equals natural log of 5. That's your vertical asymptote. Now you could have also found your vertical asymptote by looking at what happens as you approach natural log of 5 from the right or from the left. As you approach from the right, it goes to infinity. As you approach from the left, it goes to minus infinity. And so you definitely have a vertical asymptote there at x equals natural log of 5.